We're looking here at a geologic map of Yellowstone National Park, and the different colors represent different geologic units, different rock types, different ages of rocks. You can see that all of the pink units in here, these represent the very youngest lava flows, mostly, that erupted at the Yellowstone volcano. Most of these are between about 160 and 70,000 years old, and we see that they're covering up this area of the park. It turns out this is the Yellowstone caldera. It starts around here and it moves out into the area over here, and it's about 50 miles long. And it formed when this green material erupted. This is called the Lava Creek Tuff, and the age of this unit, it's found here in the light green and the dark green, also to the south, the age is 640,000 years. This was an enormous eruption, and it spread ash over much of the United States, and a similar eruption to that today would certainly be a big deal. But since this time, there have been about 80 different eruptions at Yellowstone. Some of them are very big. This one is the most recent. It's 70,000 years old, and it's called the Pitchstone Plateau lava flow. In fact, the size of it is about the size of Washington, D.C., and it's about 100 yards thick in most places. So this is what we're looking at. We can see volcanic rocks everywhere, evidence that this is a really unusual place. It's a massive volcano. Some of the eruptions from Yellowstone are truly enormous eruptions, some of the largest ones that are known of on Earth. And that includes this green unit here, the Lava Creek Tuff, as well as the purple unit, which is the Huckleberry Ridge Tuff, which is erupted 2.1 million years ago. So these are some of the largest eruptions that we know of on Earth, and because they erupted so much material, on the order of 1,000 cubic kilometers or 250 cubic miles, then they get termed as super eruptions, really big eruptions. And the way that it works, this is kind of new terminology, and super eruptions, if you're a volcano that has exploded and created one of these deposits, then you get called a supervolcano. And that's where the word supervolcano comes from. So you have this magma that's beneath the surface, and when it erupts and comes out, there's no longer support for the ground surface up here. And as a result, the ground surface just caves in, it founders and it falls in. You're left with what's called a caldera. It's a subsidence or a feature, or a cave-in feature that's caused when it loses its support of the underground magma. As a result, when it first formed, you had a hole that was on the order of 50 miles long and maybe even 1,000 or 2,000 or 3,000 feet deep in places. We have this deep magma chamber, and there's a lot of heat. The magma is generally at temperatures like 800 degrees centigrade, or something like 1,300 degrees Fahrenheit. There's a lot of heat. That heat heats up the rock, and that rock then, there's conductive cooling, there's water down there. That water gets heated up, and so much of the water that's near the surface at Yellowstone is actually at boiling temperature. And as you go down, it gets hotter and hotter. So that's creates a pressurized system of a boiling aquifer, of boiling groundwater, and that becomes unstable. It can cause earthquakes, and of course it causes the thermal features that we see everywhere at Yellowstone that make Yellowstone so famous. the geysers, the fumaroles or steam vents, the hot springs that are so beautiful and contain so many different kinds of life and thermophile bacteria. So that's what makes Yellowstone special, and it's pretty much all due to this underground magma system. So we have these massive eruptions that are really quite rare, and then we have these lava flows that happen more frequently, but still not. The last one was 70,000 years ago. But this would be a really big event if it happened again within the park. It might cause forest fires, it might dam up rivers, and it would cause a lot of commotion and anxiety within Yellowstone, but it would have very little long range effect. It wouldn't affect people in states that are hundreds of miles away, certainly. We have other big events that occur at Yellowstone. For example, earthquakes. In 1959, there was a magnitude 7.5 that occurred out near Hebgen Lake, caused a lot of damage in the park, and also caused a lot of changes to the thermal areas within Yellowstone. The Teton Fault is on the border of the Teton Mountains south of the park, and it potentially could have a very big earthquake associated with it. Beyond that, we have the hydrothermal explosions or steam explosions when the groundwater system becomes too pressurized and erupts during some sort of perhaps an earthquake or due to a change in lake level. And what happens is you get the groundwater system can form really large holes in the ground, sometimes hundreds of feet across. This is a turbid lake right here, Indian Pond and Mary Bay. All of these were created in the last 15,000 years by explosions of the hydrothermal system. In this case, no magma is erupted, and they're fairly localized events in terms of their damage, but they're still definitely relevant for what's going on at Yellowstone and need to be watched. Almost every year, somewhere in Yellowstone, there is a small hydrothermal explosion. Sometimes they might only be a couple feet across, but we find evidence for them. Sometimes we see a little bit of smoke coming out or fumes coming out in a place we didn't expect it. Sometimes somebody hears it. And in lucky cases, we actually get to witness one of these explosions, and that's happened every few years as well. We have no way of predicting these explosions, especially the smaller ones, but we hope that as time goes by, we'll get more and more knowledge about how they work, and maybe get the chance that someday we'll be able to be able to have some predictive capabilities for these explosions. I'm Jake Lowenstern. I work for the U.S. Geological Survey, and I'm the scientist in charge of the Yellowstone Volcano Observatory. Today we're going to talk about some of the eruptions that occur at Yellowstone, have occurred in the past, how big they get, how we know when they might be coming, what we need to worry about, what we don't need to worry about. The last one of these mammoth eruptions, so-called super eruption, was 640,000 years ago, and that created this green deposit, the Lava Creek Tuff. There were three of these really large eruptions. There's the Lava Creek Tuff, then there's the Huckleberry Ridge Tuff that's 2.1 million years ago, and then you can just make out down here, this is the Mesa Falls Tuff, and it erupted 1.3 million years ago. It was a bit smaller than the other two eruptions. Since the eruption of the Lava Creek Tuff 640,000 years ago, we've had a lot of eruptions within the caldera, probably 80 different eruptions both within the caldera and outside the caldera. Many of them are these really large lava flows. The most recent lava flow was down here on the Pitchstone Plateau 70,000 years ago, and it's a really enormous eruptive unit. These are big eruptions, but they're just within Yellowstone, and they don't appear to be highly explosive. Besides that, we have a number of smaller eruptions that are similar in composition. These are rhyolite lava flows. They're really sticky and gooey and don't move very far from their source. And these are in pink. We also have basalt lavas that are more similar to what gets erupted in Hawaii. It's more rapid moving material. And they're found out here outside the caldera and then out in the area to the east as well. One of the reasons that we know that Yellowstone still has an active magma system, other than the fact that there's so much heat coming out, is the fact that we never see these basalt lavas actually making it out of the caldera. And that's because it's denser than the rhyolite, and it's also relatively, it it can't penetrate through this very viscous, sticky, and less dense material. And as a result, it just ponds beneath the rhyolite magma chamber, and it loses its heat to the rhyolite. When you're outside the caldera, the rocks are cooler, and there isn't any rhyolite, and the basalt can just create cracks and come up and make it to the surface. But when you see people claiming it's overdue, usually the numbers they come up with, they say that the last eruption was 640,000 years ago, but that it erupts every 600,000 years, and so therefore it's 40,000 years overdue. But in fact, if you average the eruption intervals, there's 2.1 million to 1.3 million, and then there was another eruption 640,000 years ago, and you average those numbers, you come up with something that's over 700,000 years. And so in reality, even if you tried to make this argument, it wouldn't be overdue for another 70,000 years or so. But the other thing that is important to realize is that when anybody does statistics based on two eruptive intervals, they're just kind of playing games, because we don't know. There's no clock down there. The magma is going to erupt when it wants to erupt. There's been a lot of things that have happened over the last 600,000 years that might indicate there's less likely of an eruption. For example, about 500 or 600 cubic kilometers, or a couple hundred cubic miles, of magma was erupted just in the last 150,000 years. So you might think that that would slow the clock down in terms of the next eruption. The last piece of evidence we have in terms of the next eruption at Yellowstone is that when scientists or seismologists do tomography, when they, like a CAT scan on a human being, you do a tomographic image using seismic waves. And when they try to image the magma chamber, generally they find that the magma that's down there is not wholly molten. There may be molten bodies down there that are on the order of 100 or 200 cubic kilometers, but they don't see this massive magma chamber that's all molten material. So we don't expect that there's enough liquid magma down there to produce one of these immense eruptions as has happened in the geologic past at Yellowstone. Having said that, we don't know everything. It's possible it will erupt. It's possible it'll have small lava flows. It's possible, but not very likely, that it'll have another massive eruption. Ultimately, this is stuff that's happening 4 or 5 miles beneath us. But everything we know seems to indicate that nothing right now is truly unusual. The kinds of activity we see at Yellowstone is the kind that's been going on for the last 100 years, and from our geologic evidence has gone on for thousands of years before then. Well, occasionally we get swarms of earthquakes, and some of these swarms can be quite intense. We had one here in 2009 and the end of 2008 that was almost 1,000 earthquakes, and there were many of them that were above magnitude 3. Some of them were felt in the northern part of the lake. But that's pretty much all that happened. We had no evidence that there were any explosions that were occurring. The caldera had been moving up for a period of years, for about 4 years, and the caldera had moved up about this distance over a very broad area. But we didn't see any change that was occurring when the swarm was happening. And so we didn't really see any of the other indicators that would make us really think that something bigger was about to happen in terms of a volcanic activity.